with it. If I showed you this and said, you know, what's spinning, you'd say, I don't know, but that water's fucking curving.
Right.
That's the atmosphere. That's our planet. The difference here is the container here is a physical barrier of glass. The container on a huge mass that we call planet Earth is the mass of the planet.
Right. So the Earth moves with, well, the atmosphere moves with the Earth, but the wind doesn't move with the atmosphere.
Yeah, wind is more a product of pressure differentials, which is directly related to temperature. So just like those fish swimming around, if you had heated currents in that water, you'd have different density pockets now within that water, and they look different as well. Light would react differently through them.
Yeah, just another thing, because I know it's important to a lot of people how this can be shown in reality. If you look at any river or stream or anything, and either a boat's gone through it or you drop something into a river, you will see that there will be small vortices generated in the stream that have their own motion while simultaneously being pulled downstream by the rest of the current. So there are two separate motions there, but one smaller motion is moving along with the bigger general motion. And you can test that by looking at any stream, any flowing body of water.
See, this is what I was thinking of asking you about Stingray the other day, or yesterday, after we'd had a conversation. You know, I'm doing plumbing and I deal with water all day, and always water is, no matter what, if it doesn't have a container like those fish, water will only fill the shape of the void, and if it doesn't, it just goes to the lowest point of the floor, like all the leaks we've had and different stuff. So if it wasn't contained, I don't see how it would. The water ball thing just seems so farcical, because like our Earth, the model, because without a container, it would just slip away. I know that it's meant to be gravity. Mm-hmm. That's the thing that's sucking all this water as we're flying from space.
Not sucking, but attracting. Yes.
Not attracting. Sorry, I know. Yeah. Sorry, but it just seems farcical to me. I just don't know. I never understood it before. But it just doesn't seem plausible.
I mean, here's the thing, Gary, though. You have to, so in order for me to decide that something isn't plausible, I have to understand it enough to assert that it's not plausible with an explanation. So if I was to tell you that the molecular makeup of water is desperately, and I mean desperately, trying to be a certain shape, and that shape is certainly not flat, you'd think that's a bit weird, wouldn't you? And I'm not talking about the shape of the planet here. The shape of the planet is irrelevant. It's the actual strength and bonds within a molecule of water is desperately trying to be a sphere. There is absolutely everything about its makeup trying to be a sphere, and that's why we have surface. That's why when you drop you can bounce. You can actually bounce a drop of water on other water, and it's amazing when you see it. If you have a look for surface tension videos, and it's the same reason why a raindrop is a drop, and it's only a tear shape because of atmospheric drag. That's it. It's trying to be a sphere still. If there was no atmospheric drag, it would drop as a nice ball that would just start getting bigger and bigger and bigger because of surface tension, much like rolling a snowman through the snow and stuff. So it's not gravity is the explanation for it being on our planet. It absolutely is. So if in order to get some legitimacy to the premise that you just said, we have to throw out water, because if we're on a huge mass, if it's a planet, and if there's gravity, that explains everything. So what you now have to go to is, well, one of those components doesn't explain everything, and I'm guessing it's gravity. So because if gravity is true, then it explains it, right? If you don't accept gravity, then you don't understand the explanation, right?
obviously I've seen just a few videos on things just saying about, density, buoyancy, and I was like, and it explains it that way as well. So I don't understand. For me, I'm like, if that explains it perfectly, like I saw a guy put an iron anvil in mercury and it floated, or if you have wood, it floats above the water. If it's a rock, it falls into the water.
Mhm.
And it's that what they would say is that the rock is denser than the air. That's why it falls to the earth. And in fact, we don't need any explanation of gravity to be. We don't need any gravity.
Right. Okay. So if you don't need an explanation of gravity, I present you with the following thought experiment.
Okay.
So we're going to leave out gravity. We're going to leave out mass. I'm just going to give you the density of what's going on here, right? So I've got. Do you know what hermetically sealed is? It just means 0 in, 0 out. So I've got a glass sphere. Yeah. It's got a gas inside it. This green thing. We'll just call the gas. We'll say it's got a density of 1, right? That's what the gas has got. Now, we move this blue marble into it. This blue marble has a density of 100, right? Now, we're able to tie it there with a string or just suspend it in the middle of this with multiple strings, and then we're able to vanish those strings away in an instant. Now, when we do that, when we vanish the suspension strings, which are in every direction, all the way in an instant, and this object that has a density of 100 sat in the middle of a density that has 1, where every single direction to this sphere is equal distance and equal density, what happens to this sphere when we magic all away the strands that hold it in the middle?
I don't know. I don't know. I'm not going to presume. Does it expand? I don't know.
Well, it's a solid object in a gas. What's it going to do if we release it and press play on physics? And it's here at the moment in the middle of a gas. What's this solid object going to do?
There's no
release the gas.
It'll do what, Red?
It's going to leave the gas. It should fall right out of it if it's not contained or fall to the bottom.
Well, this here is a container of glass around it. It's got gas in the glass, and then it's sat in the middle of the gas that's in the glass. When I press play on physics, what's this solid object going to do while it's in this gas?
Go to the bottom of the glass.
Fall to the bottom of the glass?
Right, you've both said fall to the bottom of the glass. Why did you say that when you said all you needed was density? I've given you all that density, and nothing about this density says this should go down because it was equal distance and equal density in every single direction.
Sorry, I was thinking that that's a heavy object.
It is.
So shouldn't it fall?
It will. Yeah, but why? What other information do you need other than what's here to tell me what direction this is going to go? Is there anything? I've told you the gas is a density of 1. This solid object is a density of 100, and it's in a glass perfect sphere, and it's equidistant to the outside edge of the sphere. So what other information do you need to work out where this object's going to go if we press play on physics?
Nothing if you know the difference of density.
Right, yeah, so with the difference of density, what directions it's going to go? This is 100 and this is 1.
Direction if you were saying it was gravity.
Gravity, but gravity requires more information than what we've got here. This is just density. Using gravity, I couldn't tell you which direction this is going to go. There's not enough information for me, but here lies density, which is why I'm saying, just using density, what direction is this ball going to go? If we've got this glass sphere in front of us, with this gas, with a ball that's in the middle of it that is incredibly dense and solid, if we press play on physics, which way is it going to go? I've give you all the densities. How do we work out what we call the force vector? In other words, a magnitude of a direction that this is going to start going in. You both initially said down, but I'm explaining to you that there is no difference between down, up, right, and left because they're equal all around in the distance and the density. It's all one all around. Why did you say down?
I think I said down because I'm thinking of where we are now. So my mind say if I've got a cup and I drop it, so I'm thinking of where we are, so I'm perceiving that that's the heavier object and it would fall.
It is. This is much heavier object than the green gas. It absolutely is. And your instinct, and if this is in front of us now, if this is in front of us now, this perfect sphere, glass sphere, with this gas inside and this heavy object, we press play on physics, your instinct says it's going to drop down. Yeah. And you're correct. It's going to drop down. It's actually going to go in that direction. The reason why it's going to go in that direction is that's the direction of the ground. Now, I gave you all the parameters required for the density differential, and you chose to go down in a direction. Now, what I needed for gravity was to know where the larger mass is.
Where the container was.
No, the larger mass, the ground.
Yeah, but if you just told us that was suspended in the air.
It's not. It's suspended inside of a hermetically sealed glass sphere that's nothing to do with the outside. Nothing to do with the outside world, that glass sphere, in terms of density. The only thing on the outside of this sphere is a huge mass, which we call the ground. But if it's only density, then that huge mass, it shouldn't have anything to do with what's inside this hermetically sealed sphere. It shouldn't. There's nothing at all to do with the ground that should affect what's inside here. In my view, that's gravity, and I do need that flaw. In a density sense, it just isn't required, or shouldn't be.
Obviously,
right?
when I've listened to different hypotheses of why things fall, some people would say it's electromagnetic. I've heard examples of that, and I don't really know. I'm trying to figure it out, as I've said to you, Stingray, myself.
Okay. Just really quickly. So electromagnetic is electromagnetism, in other words, charge in a field, something that we can measure.
I've seen that when you've turned electromagnetic, things have stuck to objects.
No, but I mean, can we measure it? Can we measure energy put into a field?
I would think so. It's energy.
Yeah, absolutely. We can absolutely measure it. In fact, electricity running in cables is just energy into a field. That's it. So if we can measure that, then we can also measure it not being there, right? So we could build a Faraday cage and use things that are irrelevant to electromagnetism with zero charge. And we could even discharge any statics before putting them in there. And they should appear lighter. Or we should be able to charge an object and put charge into its field and it change its weight. But that's not what happens. It really, that's nothing to do with what happens. And me doing that doesn't allow me to create a flying car. It doesn't allow me to, someone who's getting electrocuted doesn't suddenly become lighter or heavier. They don't. That's not a thing that happens, even though suddenly your electrostatic potential has gone from like this infinitesimally small amount to a stupid immeasurable amount. You didn't get lighter or heavier. So I reject that as a premise, because I've stuck my finger in I was in an old farmhouse and I was changing but the weird thing is, the bayonet sort of like fittings that you have on lights. I put my hand round the top of it to push the bayonet on, but there were loose wires at the top, and I was also on a step ladder, and my God, I did not get lighter or heavier. I just fucking flew horizontally across the room. So yeah.
I did that at school, where I opened up a thermostat for the classroom, and I saw the connection point, and I had a key in my hand, and I went, I wonder what would happen if I put between those 2 points. I flew across the classroom and went into, I was like, so I don't recommend that.
Yeah, no, and I've done something worse, actually. I've done, at school, you used to have those wall sockets with the metal containers on the outside, but they always used to have holes in them And where where you could pipe external cables into, but they used to be able to just push the holes in. So I'm rocking backwards and forwards on my chair with my arms behind me. Find this fucking rim on this socket thing. Pop the little thing out of it and think, oh, that's cool, and then stick my finger in there. My God, did I wake up after that? But anyway, back to this example. Yeah, so here's another example, right? We have got mercury, water, thick oil, and air in a container. And we're able to keep them like this in this boxed container perfectly for a moment in time. Let's say we've got a magic little shield that shields them all, and they're arranged this way. If I
Sorry, what is these 4 sections?
So it says here at the top, so one is mercury, one is water, one is thick oil, and one is air.
Right, sorry.
So this is thick oil, water, mercury. Now, if I was able to press play on physics, right? So I'm able to press play on physics, and I take away these, let's say, nano particle strands of division lines from this instantaneously. What's going to happen to the fluids that exist inside this chamber at the moment? At the moment that I just, and they're on a table, by the way. So at the moment that I take all these away, what's going to happen to the fluids?
So there's a container around these fluids, though?
Yeah. It's this glass container. I can take the container away, and I'll put the container back down. Yeah.
I would say that the densest ones would go to the bottom, and the lighter ones would float to the top. It wouldn't stay that way, for example. It would go the other way, wouldn't it?
Yeah. Why, though? Because they're already arranged in the correct way, right? Mercury is denser than water. Water is denser than oil, and oil is thicker than air. So why would they reorganize themselves perfectly when they're already perfectly organized? Do you see that when I give you the density and I present you with things like this, you're still saying down? And that makes no sense if density is the only thing responsible for this. Now, think about this, though. Think about this. Let's say they do all do what you said, which they obviously will. They absolutely obviously will. They'll be arranged like this, right? If we press play on physics, absolutely will. But let's say we do something a bit interesting. Let's say now we accelerate this container off in one direction. We just keep increasing its velocity, so constant acceleration. What would actually happen? I can't actually do this here, but I should do. What would actually happen is these would start reorganizing kind of that way, wouldn't they? Because of that acceleration. It's the same as if we were to put these in a bottle and start swinging it round. Even though that bottle might stay perpendicular to the ground, they're going to start arranging outward because of the acceleration force that they're feeling while we're spinning them round. So if I can organize these in different ways based off applying different accelerations in different directions, and when I leave them to rest, they organize in this way, that tells me that there is an acceleration acting on them this way, as well as what would be forward and backwards as well. And the way that I've nearly done, check this, the way that I verify that is say, well, hang about. If there's a so-called acceleration that's happening to these liquids to make them form in this kind of way, that means I should be able to accelerate this downwards to counteract the acceleration that they're experiencing. And when I do that, they disorganize. And if I accelerate it down quick enough, they'll invert. But if I accelerate it down at 9.8 meters per second squared, they just disorganize. Now, when I stop, they organize again. When I accelerate them down at, let's say 20 meters per second squared, they organize inversely. When I do it at 9.8, they stay in a discombobulated fashion. But when I stop, they rearrange themselves. That's me doing a practical, logical experiment to now say these are under an acceleration at rest. because in every other direction I can control it, and I can even take away that acceleration by putting them in free fall, and I can actually accelerate free fall quicker, so it's not free fall anymore, and organize them upside down, but at rest they organize in this way. So in every direction I can demonstrate what an acceleration does to them, and it's the same as what's happening here. And this we simply call gravity.
And that was pretty good as well, sir. I'm just going to say, sorry, Red, I don't want to take up too much time. Sorry, Red. But I like we're talking about containers and things now. The same thing if you get a bucket and you've got water in it and you spin it round and all of the water goes that way, doesn't it? As I'm spinning it around the trees and the water's sucking. But if there wasn't a bucket there and I was just flinging it, the water would fly away. Without that container, that force of the spin, and I'm spinning round at maybe 2 miles an hour. So if it wasn't contained, that's a little thing that I'd seen a lot with the spinning ball and the water ball theory of the 1,000 miles an hour. If it wasn't contained and it wasn't a container that we were in, surely the water would dissipate away from us, wouldn't it? But on a giant ball.
Yeah, but I mean, oh, sorry, go ahead, Rocket.
No, I was just going to say, because I'll just say this and then I've got to head because it's fucking almost 1 o'clock in the morning, you psychopaths.
Thank you, Rocket.
But yeah, so there are equations which dictates how much force an object will experience when it's rotating at a certain speed. Now, a common sort of misinformation is saying that things spin in miles per hour. It's one of my pet peeves. I don't take it personally, but when you talk about things rotating, you have to talk in terms of rotational velocity, not linear velocity. Now, that merry-go-round or that bucket that you're spinning at 2 miles an hour is actually rotating several times a second, so probably 1,000 degrees a second. The Earth is rotating 15 degrees an hour. So its rotational velocity is way, way, way less than you swinging that bucket around. Now, using these equations, which can be verified, I mean, I might do it another time on a video, but using these equations, that the rotational speed of the Earth reduces or exerts a force in the opposite direction to gravity, which is 0.3% of your total weight. So if you're at the equator with your 1,000 miles an hour tangential velocity, you will weigh 0.3% less. So it is an incredibly small force. If that makes sense. Also,
I understand what you're saying there. Thank you, and thank you, Rocket. I look forward to speaking to you again. Thank you.
Yeah, and I'm gonna pull up that equation. Well, no, not the equation. Let's do a calculator instead.
Anyway, I've got to shoot now. But thanks for having me up. I'll hopefully see all you guys another time. Pleasure talking to you, Gary. Take it easy and don't stay up too late.
Yeah, and I'm gonna end this soon anyway. But cheers, Rocket.
All right, catch you in a bit.
Right. So, and and everybody follow Rocket, by the way, is really cool. So yeah, Gary, if you could get rid of like fucking 3 people and giving you recipes for fucking pizza or something. Yeah, so this is really interesting. This is a G acceleration calculator. So G, you know what a G is? A G is just, well, basically it represents 9.8 meters per second squared acceleration. So 1 G is our gravitation on the surface. Speed, or V, so this is, the equation's here, so it's V squared over the gravitation constant. So the thing here is this 1,000 miles per hour. So I've got a speed of 1,000 miles per hour. I've got a radius, so this is defining an arc that we're going to be going around at 1,000 miles per hour. And this 1,000 miles per hour only exists on the equator, by the way, as well. And I put, and it wants this in meters, so it's 6.4 million meters, right? So 6,400,000 meters. And the acceleration A that it's giving me that would occur is 0.003 G, which is what Rocket said. is 1/3%, which means. But the interesting thing here is this is just the reduction of my weight. This isn't me spinning left or right. The direction of this is upward at the equator. Right? So it's not like water is going to be going left or right because of this. Water is going to weigh slightly less because of this. Yeah, so it's not, it doesn't change absolutely anything about the direction of this water at the equator. It's just going to weigh a little bit less, like I'm going to weigh a fraction of a percent less. That's not noticeable to me, and it certainly isn't noticeable to the water. This is at 1,000 miles an hour. Okay, how about 2,000? Well, obviously, we'd just double this, and there we go. Well, actually, no, we won't. It's not a double, but we're still at just over 1%. I'm still not going to feel this. I'm still going to have to go on a diet. It's not going to help me. I'm still fucking 4 stone overweight. Wait a minute. What speed do I have to go to be not take a diet? Wait a minute. Let's say 20,000 miles an hour.
Eat them Pringles. That'll make you lose weight.
Oh yeah, no, that's the problem. No, well, yeah, no, I think that's a problem. You see, I hate them, but now I just want to eat them as well. So I think I'm in a no-win situation here. So yeah, at 20,000, I'm flung off. But at 10,000 miles per hour, yep, I do not have to diet if I can increase the spin of the Earth tenfold and live at the equator. But yeah.
The velocity outside of the equator.
Oh well, it's for me. It's incredibly. It's not a lot at all. So my latitudinal radius. Oh God, wait a minute. What am I at? 40. So I'm going to say that. So if it's 1,000, it's 1,000 miles an hour. Yeah, I'll be moving at something like, I want to say 260 miles an hour. But I'm in the United Kingdom.
So roughly like the half of the sound, half of the speed.
The speed of sound doesn't actually make that much sense in this context because the speed of sound is dependent on the air pressure. So the speed of sound is different here on the ground as it is 10,000 feet up. Yeah. So, and it's dependent on air pressure. So me traveling through that air at 250 miles an hour, that's, if we could have incredibly high pressure, that would be the speed of sound, but it isn't, not on the surface.
So at the equator, the atmosphere will be spinning at 1,000, will be moving at 1,000 miles an hour also?
Yeah, so the ground and the atmosphere that move together, give or take weather, moving at 1,000 miles an hour, tangential velocity at the equator, yes.
All right, let me sound stupid for a second. Probably a couple times. All right, so if the atmosphere...
Wait a minute. Have you got loads of cats and dogs?
Oh, bro, my wife is an animal lover. I got a lizard.
I fucking heard loads of dogs earlier on. And I'm like, I was counting like the different tones of dogs that I could hear. And I'm sure I've just heard a fucking cat now as well.
Yeah, well, you're talking to me. He just told me to let him out.
Nice. Anyway, sorry. Yeah. Back to your question.
Yeah, back to my intelligence check. So of course, correct me because, you know what I'm saying, I'm only asking because I don't know, but I would love to know. Mm-hmm. With the way airports and landing strips work.
Yeah.
The atmosphere is moving with the Earth. At what point do planes that can travel faster than the sound, at what point do they separate from the atmosphere?
They don't ever. So an aircraft requires, you need knowledge of 3 things. You need to know gravity, so the mass of the aircraft. You need to know the thrust capabilities of the aircraft. So let's say it's a combustion accelerated turbofan jet engine. So you need to know thrust capabilities of it. Then you've got the airframe and the wing, and that generates lift. So that counteracts gravity. So you've got thrust and lift. But then you've also got another component, which is due to the atmosphere, which is drag across the airframe as well. So the higher polished aircraft, you have less friction or molecular friction of air over it, and we call that drag. All the drag and lift and thrust are all dependent on the atmosphere. Absolutely 100%. So there's no manner of which that fish doesn't swim through the water or that plane doesn't thrust through the air. So when that air is moving with the planet or when that water's moving with the tank, the fish doesn't give a shit about you looking at it. The fish only cares that it's swimming through the water of weight, which would only occur on the ground anyway. None of that we care about in flight. And this is another thing about the flat Earth argument. Flight on a globe or on a flat Earth is completely plausible. It doesn't actually matter which is which. You wouldn't be able to navigate on a flat Earth. You absolutely wouldn't. But flight would still operate the same. If you wanted to have a look at this, I'll just show you this really quickly for flight on a flat Earth. Because I like this as an example. Where are we? Flight paths. Here we go. So this one. This flight path on a flat Earth is from Santiago, Chile to Sydney. On a flat Earth, it's 26,000 miles. Now, if we're talking about Mach speed, you'd have to be doing Mach 5 for it to take the 6 hours that this flight actually takes. But I won't worry about doing Mach 5 in a commercial airliner, which would break apart, by the way, because you're going to run out. You're going to run
with the atmosphere.
Sorry?
If you're flying with the rotation of the Earth, it doesn't work against or help the distance or time it takes to travel.
The jet streams will do that a hell of a lot, and pedantically the answer is yes. The jet streams and weather patterns a hell of a lot more. But what I was saying about this flat Earth flight path, this is actually a flight path that does actually occur. This flight, a Boeing 787 Dreamliner flies this from Chile to Sydney, but it'd run out of fuel here. But if it could refuel, then it'd run out of fuel here. But if it could refuel, then it'd run out of fuel here. But then if it could refuel, it'd actually make it to Sydney. But it'd still have to be doing Mach 6 to get there on time. Whereas if we look at those exact same flight paths on a globe, they're incredibly short and incredibly simple.
Well, I have to say thank you, Red, for your time as well. I know he's going to be shutting the live down soon, so I've really enjoyed this one as well.
Enlighten me a little bit, because you know what I'm saying, it's hard to find people that actually want to genuinely conversate and grow knowledge on the things you're curious about.
100%, Red, 100%. So I appreciate that. It's like 2:00 in the morning now in England, so I'm gonna hit the hay as well, but I've really enjoyed this chat as well, Stingray. So with you as well, man.
And I follow both of y'all, man. I'll definitely try to jump in here and empty my brain out again.
Yeah. No, you're always welcome back. You absolutely are, and no question. I used to teach 3D graphics in London, right? And I always used to say to I
like the page you got.
Yeah, I always used to say to students. I can always tell students that are going to fail at some point. It doesn't matter how good they are right now. They're going to fail at some point. And it doesn't matter whether it's in a year's time, 2 years' time, or 10 years' time. They'll hit a block and they won't be able to get past it. And do you know one of the telltale? I used to assign attributes to these students and say, these are the things to look out for people that are going to fail. And one of those attributes are you're afraid to ask questions for fear of looking silly. Now, that's the first stage to failure, is not asking questions and not being inquisitive. And then an ancillary thing to that is giving a shit what someone else thinks about you asking those questions. Fuck that shit.
I was a little dude, so I never really cared. All I had was my mouthpiece.
Yeah. But anyway, guys, yes, thank you for coming. I'm going to shut this down now because it is 2 fucking a.m. in England. But yes,
Yeah, man, I appreciate y'all. It's only 8 p.m. over here in Texas, man. I sure appreciate that.
Oh my God! Wait a minute! Whoa! Are you going to go and see the fucking totality then?
Oh yeah, man.
Fucking hell!
It's gonna go right over. I'm right here in Houston, so it's gonna go right over.
Nice. Yeah. But honestly, Red, what you want to do is you want to obviously look at it with solar filters and stuff like that and go, "Ooh, wow, amazing!" But just fucking.
I worked at an eye doctor's office, so I made my own lens.
Nice, but just turn around as well and have someone or have a camera set up recording the shadows, because when that sun. When the moon's moving in front and makes the sun smaller and smaller and smaller in its angular size, those shadows just become really comically, stencily kind of like hand drawn in the distance from tall buildings and stuff. And it will look utterly surreal. But everybody always looks at the sun and it's like, turn around and have a look at those shadows, because you don't see that hardly ever. Yeah,
it's crazy. Hey, but I do have one more question though.
Oh, go for it.
Like, in 2017, when I watched the eclipse happen, where the hell is the moon at before that? Because before the eclipse happened and after it, I did not see no damn moon at all. And then I was seeing a whole different part of the sky.
Yeah, so obviously that has to happen in the daytime, and you know why the sky is blue, right? So
know what happened.
All right. Oh, waters above got you. No. So yeah. So well, I took a guess at that, to be honest. No, but the thing about the blueness and the diffusion through the atmosphere is we're looking at a load of stuff being illuminated, right? And then we're seeing the wavelengths of light that reach us. But that stuff being illuminated means that we don't see the stars, we don't see the other planets, and we don't see a moon that isn't directly lit. We don't see the shadow side of the moon in our sea of blue sky. So that's why it comes out of nowhere. But Professor Nix is here, by the way. Did you come up to correct me on something, Nixer?
No, I came up since he said he was in Houston.
Oh, nice.
You're a little south of totality. You're going to have to drive a little bit up towards Dallas.
More likely I'll be in Austin when it happens.
Okay. The weather forecast for Texas is, because I was going to drive down to Dallas, is flash flooding. So just keep that in mind.
Shit.
Yeah. Come swim over here.
Yeah, no problem. But I want to point out something else that Stingray has gone over with the eclipse with you.
Yeah.
Reed, is if you're north of the line of totality, the moon only partial covers the sun. And the further north you go of it, the more of the sun you see and the less of the moon. And the further south you go, it's the opposite. We can actually measure the distance to the moon based off observers north and south of totality. Because it's a triangle.
Nice.
That's cool to know too. I mean, because that more so goes with my my curiosity of the size of the totality. But I mean, I understand it a lot better with the way Stingray explained it, which, like I said, I really appreciate someone getting to share at least to where it fine-tunes my way of thinking a little bit. It doesn't change my way of thinking all the way, but it definitely makes me question more of what I'm thinking.
Yeah, always good.
And we'll have a good discussion again, hopefully soon, Stingray. It's good to meet you, Red, and Professor. I know you've only just jumped on.
I'm gonna try, baby. So when y'all up, I'm gonna be here. Even if y'all don't let me in, I'm gonna be here.
Oh, by the way, Gary, if you can, don't follow the Dancing Monkey channel, and follow Professor Nixie as well, because he does some awesome stuff.
Okay, I'll definitely try. So that means I've got to delete 3 people.
Okay, I know, right? Okay, yeah, fair play.
Nobody follows me.
Oh yeah. Oh, wait a minute. Yeah. Guys, by the way, Professor Nixie's got 500,000 followers.
I saw.
Jesus
I like
Christ.
the elastic band thing he did the other day with the lines on it. I like
Yeah, I
that.
think I'm up to 600,000 today.
Okay, fine, whatever.
So Reed, the other thing is try and get eclipse glasses in case you do get a break. I don't want you to hurt your eyesight.
I sun gaze often. I can still see pretty good. 2010.
Yeah.
Yeah, but that
So
sun
far,
that sun gazing is very early in the morning, though, right? Because
it's about 30 minutes before, after sunrise, and about 30, 45 minutes before sunset.
yeah,
So
because
in October, 800 Americans had partial blindness due to looking at the eclipse, and it's permanent. So I don't want you to be a number.
Oh, yeah.
Okay. I don't care whether you believe in flat Earth or not. I care as a human that you don't go blind.
I appreciate that. I can't really say I'm a flat earther, but I do believe in questioning anything that I can't really prove with me just breathing.
I'm a flat earther as well, so there's two of us in here. But as I said, the Professor and Stingray have put some really good points across that I've really enjoyed their explanation of things. So,
And Gary, I look forward to talking to you personally also, man. It's like I like to see where my brain is at along with what you think also.
100%. But don't worry, I'll try and get rid of the fourth person later.
Hey, I appreciate it, man. I appreciate you.
Wait a minute,
wait
a minute, Professor. How many people do you follow?
I think about 500.
Wow. Do you know that? Do you know there's a limit to the amount of people you can follow?
10,000.
Yeah.
No, see?
I probably heard it while we were discussing. Or did you know that before that?
I knew that before.
Yeah, right. Fair enough. Wow.
You know there is no limit anymore to your block list, and I have the second highest block list on TikTok.
Holy crap!
I have 62,000 accounts.
No way.
What do you mean they blocked you, or you blocked them?
I blocked them. My lives are insane.
Is it loads of flat earthers going crazy and losing their minds? Like, you don't know nothing, Professor! They start screaming and stuff. Is that what it is?
Yeah, I have no conspiracy theory policy in my lives, and I show the sun, solar flares live. I show the moon. I show galaxies, nebulas, and my moderators have a zero tolerance policy because I have lots of kids who are homeschooled or at school learning about the science, and I have no tolerance for it.
And you also you also show as well, Professor. Don't sell yourself short, like practical things in your room, like quantum locking, which is fucking amazing just to see.
Yeah,
I love shit like that.
Yeah, last night was the cloud chamber showing radioactive decay.
Oh no, I've seen that. Oh yeah, where you have an alcohol vaporous substance, and then you see. And then it's interacting with something. I can't remember. I always wanted to set that up, but the weird thing is, like the availability of these compounds, including things like dry ice and things like that. You guys can just go, like, you can mail order these things. We're so limited in the UK. It's very hard to get anything that would like produce, to be able to do these experiments. It's a bit weird.
Yeah, I literally go to my local grocery store for dry ice. Liquid nitrogen, there's 5 places, and they're all welding shops where I can get liquid nitrogen.
Nice. But yeah, no, you want to have a look at the quantum locking, Gary. It is really cool.
That sounds quite interesting.
Stingray, are y'all any kind of religious or
me? Absolutely not. I don't mind Christians. I don't mind religions. I don't mind faith. But the one thing that I would be wary of with faith-based belief systems is faith teaches you not to question. Yeah. And that's Yeah, and that's very dangerous. That's very dangerous in if you use that in an applied sense. So if you mix the physical and natural world, so what we call science is the study of the physical and natural world. All of that's always going to be beneficial to you in your present situation within reality. Faith, which teaches you not to question things and accept things without evidence or being able to demonstrate them, it's very important to have a division between those two to be successful in kind of both, to be honest.
But that doesn't really coincide with Christianity. I mean, not that I'm a Christian, but as far as Christianity goes, it's like supposed to walk by faith, not by sight. And
all of the top.
So
Sorry, go on, man.
question everything without disregarding it. Like, you don't just believe it because you haven't been taught not to believe it. Choose it not to be fact.
Well,
You know,
I'll let you into a little secret. The Bible says that about 10 times, and then it tells you what to believe about 100,000.
Okay, touche.
Be wary on that.
I'm close on that.
Because back in the day, were Christians like you know, from the 18th centuries and the 17th centuries. Some people would give the argument of, oh, that was what was around at the time, so that's why. But I don't know. I just think
Garrett, we'll have a discussion about religion one time when I've got the headspace for it, and it's not 2 fucking a.m. for the both of us, right? Okay.
Yeah. Let's shut up. Let's get y'all out of here so I can keep doing that.
All right. Anyway,
and I'm going to drop back down. I just came up to help Reed with the eclipse. I just wanted to make sure he'd get the best opportunity to see it.
Yeah, cool.
And it's just so y'all know, it's red. I do music. It's an acronym I live by: ready, eager, anxious, determined.
Oh, nice. Yeah, oh, fucking hell! Wait a minute! Whoa! Red, Gary, before you go, fuck me. There's you, Rosie, and now Red.
Yeah, I told you I'll do their ad libs, bro.
Yeah, fuck me. We can almost start a band here. Seriously, this is a TikTok band. Jesus.
We just get you on beatbox.
Yeah. Right. Anyway, guys, it's been a pleasure. I've enjoyed it, and I shall catch you all later.
Take care, man.
All right, man. Appreciate y'all.
Laters.
Bye.
Right, guys. Yes, interesting talk. A bit of drama to begin with, which I shall contemplate on and actually do a little bit of research of what the hell all that is about. Because I know Nathan. I still don't know whether he's changed or what he's done recently. So I'm gonna look into that and see how I feel about it. And I certainly won't go into a live while he's there anyway, because I did go into one live once when he was there, and I didn't realize he was there. And I've known him from the YouTube days, like I say, a decade ago. And I didn't. He asked me a few things, and I told him a few things and said, let's just do this. And then he just shut up. So, but anyway, yes, guys, thank you for coming in. Thank you for joining us. I did enjoy the chats, and I do enjoy it when I limit the amount of people up here so we can have decent conversations, which unfortunately does mean that I can't allow everybody up. I think that's a better format, to be fair. So apologies if you didn't get a chance to come up. Do message me and say, hey, I'd like to come up. I've got some things I want to discuss or some questions and all that kind of stuff. And I'll try and make a mental note. But when I just get loads of requests, unfortunately, most of the time, even if it's people, sometimes I won't even see people that I know that I would want to come up. So it's a bit difficult because I want to limit it, and then I get so many requests. So don't be put off by that, but do message me and say, oh, is there a possibility that I could come up on a live? And I'll mentally have that there to look out for you rather than just seeing this sea of fucking names. But anyway, guys, thank you for very much for coming. I'm going to release a few videos in a few days about the orientation of the moon and some of the shit. So keep an eye out for those, and I shall catch you all later. Bye-bye.